Hi and welcome to Maths class. Today we're looking at an introduction to sampling and estimation. So what is sampling? Well, quite often we have a big question that we need answered and we have a population. The question is about a population. For example, it might be a question about adults or it might be a question about eucalyptus trees. And it's impossible for us to go and examine each eucalyptus tree in the world or every adult. So we take a sample and we hope that the sample will teach us something about the population. So for example, what proportion of people eligible to vote in Victoria intend to vote Liberal in the next state election? It's not practical to go and ask every person. I mean, we do that in the election itself, but not in the lead up. So we'll take a sample of people and ask them how they intend to vote and hope that that gives us information about the population itself. Here's another example. What proportion of Year 12 students have a part-time job? Again, I can't ask every Year 12 student, so I take a sample. What proportion of penguins in Port Phillip Bay have been entangled in fishing wire? So I would go to Port Phillip Bay and take a sample of penguins and check if they've been entangled in fishing wire. And that will hopefully tell me something about the population. What proportion of adults will experience drowsiness as a side effect of this medication? Another example where I would need to take a sample. So if I take a random sample from a population, what can I learn about the population? So I'm just going to change my screen here because what I'm going to show you is I've got this cup. And in this cup, I've got some little trains, red and green trains, just from a toy. So you don't know how many red trains and how many green trains I've got in this cup. So what we're going to do is take a sample and see what it tells us. I'm going to take a sample of 5. So I'll just choose 5 trains at random. And there we go. I've got 3 green and 2 red. So what's the proportion of trains in the cup that are red? It looks to me, I've got 2 red, it looks like 2/5 are red, about 0.4. So that's my sample. But is that really what's in the cup? Right? Now, how can I work out exactly what information? Because it's a very small sample. It could just be randomness. There could be way more red than green. There could be way more green than red. It could be something different. So what we're going to explore, I'll just change my screen again, is, first of all, we're going to learn about sampling and about key definitions, and that's going to be in this video. Then we'll explore what probabilities I can calculate when I know the population proportions. So now I'm going to tell you that half the trains in this cup are red. You would now be able to help me calculate the actual probability of this particular sample being drawn out. 2 red and 3 green. Then we're going to look at the distribution of different possible samples. So all the different things that can happen. I could have chosen no red. There could have been 1 red. There could have been 2, could have been 3, could have been 4, could have been 5. Okay, so this is where we're coming back to distributions. We're going to see that there's a distribution of samples. And then finally, we're going to take what we've learnt and we're going to go back to imagine if you don't know what's in this cup, then what can this sample tell me? How much information can I pull from that sample about what I think is probably in the cup? Okay, so for today, some key definitions. Population is the set of all eligible members of a group. So in this cup, the population is all the trains in the cup. The sample is the subset of the population, and you just saw me pull out 5 trains. That was my sample. So a simple random sample, which is what I drew, is a sample where I have drawn every element of that sample randomly. Not all samples when we do research are random, but it is the gold standard because it means that I'm most likely to have good information about the population. So here's I'm just reproducing my sample, okay? There's my sample. To be a simple random sample, 2 things have to be true. Firstly, every subset of size n has an equal chance of being chosen. Now that doesn't mean that this particular combination has an equal chance, But this exact sample, so I've got 5 trains here. If I numbered all the trains in this cup from 1 to 50, there are 50 trains in the cup, then these particular trains have been chosen, but there are 50 trains and so therefore there's a very large number of combinations of samples. So it has to be true that every subset, every possible sample is equally likely to be chosen. And then secondly, every member of the population must have an equal chance. So this train had exactly the same chance of being chosen as every other train in my sample. Okay, so how do I generate a random sample? Obviously, we can't always put things in a cup and pull them out. If I'm dealing with penguins in the bay, or if I'm dealing with adults, I can't necessarily just, put them in a cup, shake it around and make it random. So this is our technique. What I do is I assign a number from 1 to 50 for every train in the cup, okay? And then I'm going to use my CAS calculator to generate a series of random numbers for my sample. So just give me a moment to set that up. So there's my CAS calculator. So what I'm doing now is I'm just opening up the CAS and I'm going into main. Now, if you've got a different kind of calculator, then it might look slightly different, but there will be something similar in your calculator to do this. I'm going into keyboard and I'm going to go down to catalog, and I'm just going to scroll across until I come up with the number R, because the command I'm looking for starts with rand, which stands for random. So rand list I choose and I hit input. Now let's just say I wanted a sample of size 10 out of the 50 trains in here. So I've labeled each train from 1 to 50. Each train has its own number. And so now I just put in 10 because I want a sample size of 10. So I want 10 random numbers from 1 to 50. Hit enter, and there are my 10 random numbers, okay? So what I would then do is, if there are any duplicates, I would just generate one more random number and not count the duplicates. All right, so that's my list of random numbers. That's how I can make a simple random sample when I have a reasonably, when I have a countable population. Okay, get rid of that. Now, here are a couple more key definitions for you. So I've got my population proportion and I've got my sample proportion, and I call those P and P hat. That little symbol I'm just going to call hat. So the population proportion in this cup is the proportion of red trains. Okay, if I'm interested in how many trains are red, then it's trains that are red out of how many total trains there are. That's my population proportion. It's constant. It doesn't change no matter what happens in my sample, and so it's called a population parameter. Now, the sample proportion that you saw me pull out was 2/5 because I had two red trains out of a total of 5. So that means that my proportion in the sample was 2/5. But look, let's take another sample. Give it a shake. Make sure every train has a good chance of being chosen. And now, without looking, I'm choosing 5 trains. 1, 2, 3, 4, 5. Okay, let's see what I've got. 2/5 again. Okay, 2/5 again. That didn't really illustrate what I wanted to illustrate. So let's take another sample. Really good shake. Another set of 5. 1, 2, 3, 4, 5. Okay, this time I've got 2 green and 3 red. There's my 3 red. So this time my P hat, my sample proportion, is 3/5. So it varies from sample to sample. A different sample might give me a different value for P hat, and that is called a sample statistic. So that's the difference between the word statistic and parameter. Parameter is for the population and it doesn't change. The statistic is just for my sample. And so just finally, These are the ways we calculate those two values. P is the number in the population with the given attribute over the population size. So in this cup, there are 25 red trains out of 50 trains. So in fact, P in this cup is 0.5. P hat is the number in the sample with the attribute divided by the population size. So in the first sample I took, that was 2 red trains over a sample size. Did I say population size? Sorry, over a sample size of 5, so 2/5. And that's all you need to know from this video.